Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 1 for October 2023. Let's begin with the first question. Question 1. An atom of aluminium forms an ion of aluminium 3+. What are the numbers of protons, electrons, and neutrons in this ion? To convert aluminium atom into aluminium ion, 3 electrons must be lost. However, the numbers of protons do not change, they're still going to be 13. Here, the numbers of neutrons are going to be 27 minus 13, meaning atomic mass minus the number of protons or atomic number, which is going to be 14. So the answer is going to be D, 13 protons, 10 electrons, and 14 neutrons. In question 2, what is the shape of a p orbital and the maximum number of electrons it can hold? Remember, this question says a p orbital, not p orbitals. So a p orbital has a dumbbell shape, but it can hold a maximum of 2 electrons, so the answer is going to be C. Moving on. The formula of calcium carbide is CaC2. What is the formula of the carbide ion? If carbide was C2 and then a -1, we'll produce something like that. If it was C2 plus, then it won't make sense because calcium is already 2 plus, no possible interaction to form an ionic bond. If it's C2 minus, we produce something like this because that cancels with that and we produce that. And if it's this, of course, 2 cations, nothing. So the answer is going to be a C, giving us that. In part B, excess calcium carbide and 10 grams of water react to form the hydrocarbon ethyne, carbon 2, hydrogen 2. So this is the reaction. They say what is the mass of ethyne that forms, assuming a yield of 100%. I'm going to begin by getting the number of moles of water. Moles of water should be the mass of water divided by the molecular mass, which is 18, giving us that. So I'm going to use the moles of this to find the moles of ethyne. Moles of ethyne are going to be 1/2 times the moles of water, giving me that. And so the mass of ethyne is going to be 7.22 grams. And assuming it's 100% yield, percentage yield should equal to 100, which is equal to the actual yield, divided by theoretical times 100. So the actual yield is going to be 7.22 grams. And the answer is going to be A. And for this part, even if you had not calculated the percentage yield, remember we always assume 100% yield when the theoretical yield and actual yield are going to be the same. So here it's going to be 7.22 grams. Without calculating this, the answer should be the same. In question 4, which diagram best represents the electron density map of sodium chloride? Remember, sodium chloride form ionic bonds, so these that have overlap are going to be cancelled out. Also, sodium cation is smaller than chloride anion, so this is going to be cancelled out and the answer is going to be A. In question 5, what types of bonding are present in the compound ammonium chloride? Here I drew the ammonium and then the chloride. Of course, there is an ionic bond between a cation and anion. However, we also have some covalent bonds and a dative covalent bond, so the answer should be D. There is an ionic bond, covalent bonds, and a dative covalent bond. In question 6, the electronic configuration of the atoms of 4 elements are shown. What is the electronic configuration of the atom of element which has the lowest first ionization energy? In A, there is no 3p, so this is out. It means the number of shells are fewer. However, when we go to B, C, and D, there are 3p orbitals. So here we have 1 electron in the 3p, 2 electrons, and 3 electrons. However, here the number of protons is 15, here it's 14, and here it's 13. These ones are going to be stronger or held stronger because the protons are more and here they are more. So this is going to have the least. Not because it has 1 electron, but because the number of protons are going to be fewer. So the attraction from the nucleus is going to be less in comparison to the others. So the answer should be a B. In question 7, a direct electrical current was passed through a green solution of copper 2 chromate in the apparatus. Here the green color is because copper 2 is blue and chromate is going to be yellow, so a mixture of the two creates the green color. And we know copper 2 is positive, so it's going to go to the negative electrode, which is this one here. So we will see a blue color here. Since chromate is the anion, it's going to go towards the positive electrode, and we'll see it's going to form a yellow color here. So down here they say which colors would be seen at the electrode after several minutes. The negative electrode, because the blue copper goes there, we're going to see a blue color. And the positive electrode, because the chromate anion, which is yellow, goes there, we're going to see a yellow color, and therefore the answer is going to be a C. In question 8, In which region of a mass spectrometer are particles ionized? Ionization takes place here. Remember, this is vaporization, ionization. There is acceleration, there is deflection, and then detection can take place, so it's going to be region Q. Question 9. A sample of the elements chlorine was analyzed in a mass spectrometer. Chlorine has 2 isotopes. What is the total number of peaks due to ions with a single positive charge, which could be seen in the mass spectrum? So we're going to have the isotopic peaks as well as the molecular ion peaks. Isotopic peaks are going to be chlorine 35 and chlorine 37, which is 2. But the molecular ion peaks could be because of 2 chlorines, 35-35, because of 2 chlorines, 35-37, or because of a mixture of chlorine 35 bonded to chlorine 37. So the total number of peaks is going to be 5, and C is going to be my answer. Question 10. Propene, which is that reacts with hydrogen chloride to form halogenoalkanes. Which of these steps is most likely to occur in the reaction? Since this is not symmetrical and we are reacting it with a non-symmetrical molecule, it means there is a possibility of forming 2 products, one through formation of a major carbocation and the other through formation of a minor carbocation. And since the question said most likely, it means we're going to go with the one for formation of the major carbocation. And to do that, the hydrogen will bind here and the Cl will have to bind here. So we're going to have a C plus here, which will later take the Cl. So this is going to be the answer. In part B, the reaction of propene with hydrogen chloride is an example of course, this is going to be an addition reaction and an electrophile attacks during the mechanism, so it's going to be electrophilic addition. Question 11. Ethene reacts with acidified potassium manganate 7. A student makes 4 statements about the reaction. The organic product can show geometric isomerism. This is wrong. The organic product is going to be a diol, and there is no geometric isomerism because the carbon-carbon double bonds are not there. Then the type of reaction that takes place is oxidation. This is true. The bond angles around each carbon atom are greater in the product than the reactant. No. The reactant had bond angle 120 like you see here, and the product has bond angle 109.5 because it's tetrahedral around the carbon. Then the acidified potassium manganate 7 decolorizes in the reaction. The color changes from purple to colorless, so that is correct. So they ask how many of these statements are correct. It's only 2 statements, this statement and that statement. In question 12, concentrations in mixtures can be given in units of parts per million, which is ppm. A sample of a gaseous mixture contains 2.19% carbon dioxide by mass. What is the concentration of carbon dioxide in parts per million by mass in this sample? So we know 2.19 grams of carbon dioxide in 100 grams of gas. So the concentration should be 2.19, which is the mass of carbon dioxide divided by the 100 times 10 power 6, and it's going to be 2.19 times 10 power 4 ppm. So B should be my answer. In 12b, a solution of lead nitrate has a concentration of 15 ppm by mass. What is the mass of lead nitrate in 400 grams of this solution? Remember, concentration in ppm should be the mass of lead nitrate divided by the mass of solution times 10 power 6. So the mass of lead nitrate is going to be 15 times 400 divided by 10 power 6, giving us 6 times 10 power negative 3 grams. And so the answer is going to be A. Question 13. Which solution contains chloride ions with a concentration of 0.05 mole per decimeter cubed? So they've given us the atomic masses. 1 mole of calcium chloride contains 2 moles of chloride because you can see CaCl2. So to find the moles of chloride in calcium chloride, I'm going to find the moles of calcium chloride and multiply them by 2. And then to find the concentration, I'll divide the number of moles by the volume in decimeters cubed. So here my concentration should be number of moles over volume, and the number of moles are going to be twice the moles of calcium chloride. So 2 times 1.39 divided by 111.1. That is the number of moles. Then divide by the volume, which is 250. Converting it to decimeters cubed is going to be 250 times 10 power negative 3. This gave me 0.1 mole per decimeter cubed, and that's not my answer. When we go to calcium chloride, still it's going to be twice, so concentration is number of moles over volume, which is 2 times 1.39 divided by 111.1 divided by 500 times 10 power negative 3, and this gave me 0.05 mole per decimeter cubed, which matches with that. For the others, sodium chloride contains 1 mole of chloride, so the number of moles of sodium chloride are equal to the number of moles of chloride. So since moles of sodium chloride are mass divided by the molar mass, which is mass divided by 58.5, then divide by the volume in decimeters cubed, you can see I got 0.1 and here 0.02. So B was the only one that gave me 0.05, and so B was my answer. In question 14, the formula of oxygen is COCl2. What is the total number of atoms in 9.9 grams of oxygen? The number of atoms should equal to the number of moles times Avogadro's constant. But here we have 4 atoms, which is going to be 2 chlorines, 1 oxygen, and 1 carbon. So it should be 4 times the number of moles, which is going to be 9.9, which is mass, divided by molar mass, which is 99, times Avogadro's constant. And multiplying everything, I got 2.41 times 10 power 23 atoms. So this should be my answer. In question 15, what is the number of structural isomers with a molecular formula carbon 5, hydrogen 12? We have this when it's a straight chain. Of course, 5 carbons in a line, and then 4 carbons and 1 branched off, and then 3 carbons and 2 branched off. So they're going to be only 3 possible structural isomers. Question 16. A cyclic hydrocarbon has the structure shown. So they say how many pi and sigma bonds are present in the molecule. I place the carbons and the hydrogen so that we can see. I'm going to go with the sigmas first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 sigmas and we have 2 pi's. So the answer is going to be 2 pi's and 11 sigmas, and that is going to be A. In question 17, a technician is asked to store 4 reagent bottles safely. The only information about each substance is the hazard label on the bottle. So here we see W has oxidizing, this is flammable, this is corrosive, and that is toxic. They say based on the hazard labels alone, which 2 bottles should never be stored together. Never store together something that is oxidizing and flammable, because the oxidizing one can produce oxygen and the other can catch fire. So it should be W and X. So this brings us to the end of question 17 as well as to the end of section A. Let's continue to section B. Question 18. This question is about the elements in period 2 of the periodic table. They say the first ionization energies of some elements in period 2 are shown, which we can see here. Let me shift this away so that it's easy for you to see. So they say explain the general trend in first ionization energy across period 2. Across period 2, first ionization energy increases. Again, that is the statement, but we have to give a reason for that. The reason is we're adding electrons to the same number of shells. However, the number of protons is increasing, so the attraction from the nucleus is greater, yet all the atoms experience similar inner shell shielding. So the outer electrons are going to be attracted further or attracted more in neon in comparison to lithium and the others, and that means it's going to increase across the period. So I said across the period, first ionization energy increases in magnitude. The number of protons increases across the period, leading to higher nuclear charge and attraction towards outer electrons. Since electrons are all removed from the second shell, they experience the same inner shielding. Next is a predictor value for the first ionization energy of oxygen, and they want you to just file your answer. So if we look at the electronic configuration, oxygen is going to be 2p4, this is 2p3, and this is 2p5. So it's going to be in between here. So I chose 1320. So I said 1320 kilojoules per mole. Of course, acceptable was within that range, because in oxygen, one of the p orbitals has paired electrons. Of course, due to pairing, repulsion is going to occur, and it's going to be easier for that electron to be lost, meaning the ionization energy is going to be closer to nitrogen and further from fluorine. So this leads to repulsion, lowering the first ionization energy. In part B, the second ionization energy of lithium is 7298 kilojoules per mole. Write the equation for the second ionization energy of lithium. I want you to include state symbols. Since this is the second ionization energy, it means lithium is already an ion but in gaseous phase. So lithium ion in gaseous phase becomes lithium 2 plus ion in gaseous phase by losing an electron. And next they say explain the large difference between the first and second ionization energies of lithium. If we look at the electronic configuration, lithium should be that and that. So the first ionization energy removes that electron that is in an outer shell and not paired, but the second removes the second electron, which is going to be in the 1s orbital, and it's going to be paired. So there is repulsion here. However, this is in an outer shell, so this is going to be lower. So I said both lithium and lithium plus have the same number of protons, so they possess the same nuclear charge. The first electron is removed from a 2s orbital, that is for lithium, while the second, meaning lithium plus, is removed from the 1s orbital. 2s electrons experience greater shielding than 1s electrons, lowering the first ionization energy, and the 1s electrons are closer to the nucleus and thus experience greater attraction than the 2s electrons. In part C, beryllium reacts with chlorine to form beryllium chloride. In the gas phase, beryllium chloride exists as both simple molecules, which is that, and as dimers. Draw a dot and cross diagram of the molecule BeCl2. Beryllium has 2 electrons in the outer shell, and because it's forming covalent bonds with 2 Cl's, this is one covalent bond and that's the next, so all electrons in the outer shell are used up, so this is going to be the structure. Then they say explain the shape and bond angle in the molecule of BeCl2. The shape is going to be linear and the bond angle is going to be 180. The explanation is in beryllium chloride we have 2 bond pairs. Due to repulsion, the structure rearranges itself into a linear structure with bond angle 180 to minimize repulsion between the bond pairs of electrons. And here they say draw a diagram to show how 2 beryllium chloride molecules bond together to form dimers, which is that, stating the type of bonds involved. So this is going to be one beryllium and the other. Of course, remember beryllium can form 2 covalent bonds, so we have that and that. In the other side, we have this beryllium with that and that. There is a dative covalent bond formed around each beryllium from a chlorine of the corresponding molecule, so the structure comes out like that. So the type of bond involved is going to be a dative covalent bond, and that should be the answer. So this brings us to the end of question 18. Let's continue to question 19. Question 19, many cars use fuels containing ethanol as well as hydrocarbons. The E number of these fuels shows the percentage by volume of ethanol in the fuel. For example, an E5 fuel contains 5% ethanol and 95% hydrocarbon by volume. In part A, a brand of E10 fuel contains 92.2% hydrocarbons and 7.8% ethanol by mass. The energy density is the amount of energy released per kilogram of a fuel brand. The energy densities of the 2 components of this brand fuel are shown. Energy density of hydrocarbons is 46.5 megajoules per kilogram, and the energy density of ethanol is 29.7 megajoules per kilogram. They want you to calculate the mean energy density of this E10 fuel in megajoules per kilogram and give your answer to an appropriate number of significant figures. So to calculate the mean energy density, I'm going to get the portion of hydrocarbon plus the portion of ethanol. Remember, we have 92.2% and 7.8%. So 92.2 divided by 100 times 46.5, which we have here, plus 7.8 divided by 100 times 29.7. And this gives me 45.1896, which is 45.2 megajoules per kilogram. This is to 3 significant figures. The density of the E10 fuel is 0.729 gram per centimeter cubed. Calculate the mass of 1,500 centimeters cubed of the fuel. We know mass is density times volume, so the density times the volume, which is that times that, gave me 1093.5, which is 1094 grams, if I round off. Next, they say calculate the energy released when 1,500 centimeters cubed of the E10 fuel is burned in excess oxygen, using your answers from A1 and A2. If you did not calculate the value of the mean energy density of the E10 fuel, use a value 38.1 megajoules per kilogram, but this is not the correct answer. From above, I have 1093.5 grams. Divide by 1,000, I get 1.0935 kilograms. So E is going to be mean energy per kilogram times the mass in kilograms, which is the 45.1896 times 1.0935, giving me 49.414827. Rounding off to 3 significant figures, it is 49.4 megajoules, and that was my answer. In part B, they say many countries are gradually replacing E5 fuels with E10 fuels. Remember, this is the composition of E5s, and that is the composition of E10s from the question. Let's explain how this change might result in a more sustainable fuel. If we look at E5, there is 5% ethanol, but here there is 7.8% ethanol, meaning there is fewer hydrocarbons that are used, so It is more sustainable because the ethanol percentage is higher and we can produce ethanol using biological means that decreases the amount of fossil fuels that are going to be used. So I say the E10 fuel contains less hydrocarbons than the E5 fuels, so less overall carbon dioxide emissions will occur, less global warming, and less climate change. Here we're talking about the net emissions. Hydrocarbons are from fossil fuels, which are a finite source. Ethanol can be obtained from plant materials. In part C, the straight chain alkane hexane can be reformed to give a range of products. It was suggested that one such reaction may produce a cyclic hydrocarbon and hydrogen gas as the only products. The cyclic hydrocarbon contains a ring of 5 carbon atoms. Write the equation for this reaction using molecular formulae. State symbols are not required. So of course, carbon 6 hydrogen 14. If we take away hydrogen as a molecule, we still get carbon 6, but now we have 12 hydrogens plus H2. This is actually looks like an alkene, but remember, it's not. If it was an alkene, it could be hexane, because this is hexane. However, this is a carbon ring, meaning it has 5 carbons. Therefore, one carbon is going to be branched out. So they said draw the structure of the cyclic hydrocarbon formed in this reaction. It's an alkane with a CH3 branched on the side. In part D, hexane will react with chlorine in the presence of UV light to form a number of products. Describe the role of the ultraviolet in the initiation step of this reaction. Of course, UV is going to split the Cl-Cl bond evenly, and this produces free radicals, which are like that. Next, they say the alkane dodecane, carbon 12 hydrogen 26, is formed in this reaction. Write equations for the propagation step and the termination step for the formation of this product. Use molecular formulae in your equations. To form these from a 6 carbon compound, it means carbon 6 hydrogen 14 plus a chlorine free radical formed carbon 6 hydrogen 13 plus HCl in one propagation step. And then in the termination step, it means 2 radicals of these came together to produce carbon 12 hydrogen 26, and this is what I showed here. So that is how this dodecane could be produced. So this brings us to the end of question 19. Let's continue to question 20. Question 20, this question is about alkenes. A straight chain alkene X has the structure shown, which is that. They said draw the skeletal formulae of the 4 structural isomers of X that are alkenes, do not include geometric isomers. So for the first one, I took the double bond to be on carbon 1 and I created that. Then for the next one, I branched off. So branch off 1 carbon and put it here, and I got that. For the third one, if I take the double bond here after branching, I got that. And then this could be taking this to the other carbon and leaving it in this manner, I got that. So those are the 4 possible alkanes that could be formed. And again, I wrote them here using their structure formulae. Next is explain why X can exist as geometric isomers. Of course, they can exist as geometric isomers because they have carbon-carbon double bonds with restricted rotation. This is a prerequisite for anything that should be a geometric isomer. And of course, on each of the carbons along the carbon-carbon double bond, there are higher priority groups on each carbon in the carbon-carbon double bond. In part B, another compound Y has the structure shown, which is this. Give the IUPAC name of Y. To name your number from left to right and right to left, this is carbon 1, 2, 3, 4. And when I do that, I have a 2 and 3. On the other side, carbon 1, 2, 3, 4, I have a 2 and 3, so it doesn't matter whichever way. However, this is an E isomer because the priority or higher priority groups are on opposite sides. So it's E, 2, 3, dichlorobutene because the double bond is on carbon 2 either way. Next, they say a student said that compound Y has polar bonds, so it's a polar molecule. Comment on this statement. Now we can see the bonds are polar because there is a carbon and a Cl bond, and since chlorine is more electronegative than carbon, there is a difference in electronegativity that causes polarity. However, the molecule is symmetrical and so it will not be polar. So I said the student is correct about polarity of the bond but wrong about polarity of the molecule. Chlorine is more electronegative than carbon, so the carbon-chlorine bond is polar. However, the molecule is symmetrical with no net dipole, so the molecule is nonpolar. Betabolines are a group of compounds found in plants and fungi. Bisobolene molecules contain several carbon-carbon double bonds. 5.51 grams of alpha bisobolene reacted with 1873 centimeters cubed of hydrogen gas. The reaction occurred at a temperature of 150 degrees Celsius and the pressure of 152,000 pascals. So they've given us the molecular mass. They say calculate the amount in mole of alpha bisobolene in 5.51 grams. Number of moles should be mass divided by the molecular mass, which is given here, and we get 2.70098 times 10 power negative 2, rounding off to 2.701 times 10 power negative 2 mole. Next, they say calculate the amount in mole of hydrogen gas that reacted with alpha bisobolene. Use the ideal gas equation, PV is equal to nRT. If PV is equal to nRT, then N is PV divided by RT. The pressure is given in pascals, so we can substitute it the way it is. The volume should be 1873 times 10 power negative 6 meters cubed, and the temperature 150 degrees plus 273, which is 423 Kelvin. And to substitute, pressure equal to that, volume equal to that, then R equal to that, and the temperature equal to that. And calculation using a calculator, I got 8.099 times 10 power negative 2 mole as my answer. The next I said is use the number of carbon-carbon double bonds in a molecule of alpha bisobolene using your answers in C1 and C2. Remember, we have the moles of each. These are the moles of hydrogen, but we also have the moles of alpha bisobolene, which is that from the first part. So the ratio is going to be that to that, which is 1 to approximately 3. It means 1 mole of bisobolene required 3 moles of hydrogen, and that means it had 3 carbon-carbon double bonds, so that should be 3 of them. And in part D, the repeat unit of the polymer polyisoprene is shown, which is that. There is a double bond here already, but to draw the monomer, ignore the extension bonds and then put a double bond here. So this is what we have. A sample polyisoprene has a relative molecular mass of that. Calculate the number of repeat units in this sample. So I drew the polymer, which we have here, and we can see the carbons are 1, 2, 3, 4, 5, and the hydrogens are 8. So the molecular mass of the repeat unit is going to be 68. So since we have the relative molecular mass of the whole molecule or the whole polymer as 50 to 50, that divided by that gave me 738.97. This is approximately 739 units, so there are 739 repeat units. In part E, incinerators used to dispose of polymer waste have a system to remove waste gases. Suggest why these systems contain solid calcium hydroxide and why it is finely powdered. Calcium hydroxide neutralizes the acidic gases and is powdered to increase the surface area for the reaction to be faster. So I said calcium hydroxide neutralizes the acidic gases like HCl, carbon dioxide, oxides of nitrogen, and oxides of sulfur. It is finely powdered to increase the surface area to attain a faster rate of reaction. So this brings us to the end of question 20. Let's continue to question 21. Question 21. This question is about minerals containing metallic elements. The green mineral zeratite contains basic nickel carbonate, which is that. Basic nickel 2 carbonate can be formed by the reaction of nickel 2 sulfate with sodium carbonate under alkaline conditions as shown. They say calculate the relative formula mass of basic nickel 2 carbonate, which is that 3 times the atomic mass of nickel plus 1 carbon, so 1 times the atomic mass of carbon, 3 times the atomic mass of oxygen. Hydroxide is going to be 16 plus 1, which is 17, so 4 times 17 plus 4 times 18, because each water molecule is 18. And adding everything up, I get 376.1. There are no units here because this is relative formula mass. Next, I say calculate the atom economy by mass for the formation of basic nickel 2 carbonate by the reaction shown. Atom economy by mass should be the molar mass of the desired product divided by the molar mass of all products. So 376.1 divided by the total, which should be 376.1 plus 3 into 142.1. Multiplying that by 100, it gave me 46.9% to 3 significant figures. Give the reason why use of the term relative molecular mass is not appropriate. It's not appropriate because we have some metal. Nickel is a metal. Metals are not found in molecules, so because the structure of basic nickel 2 carbonate is a giant structure, of course, Nico is going to give a giant structure, so we cannot call it a molecule. Chemists often simplify full chemical equations into ionic equations by removing spectator ions, give the electronic configuration of Nico ion present in Nico 2 compounds. Nico 2 is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d8. Of course, it has lost the 2 4s electrons. Next, they say, write the ionic equation for the formation of basic Nico 2 carbonate from Nico 2 sulfate. State symbols are not required. We have the 2 sodiums and the 4 sodiums, totaling to 6, and the other side we have 6, so those cancel out with that. And we have 3 sulfate and 3 sulfate here, they cancel out. Whatever that remains is going to be this, and that is going to be the ionic equation for this reaction. In part C, another basic carbonate found in minerals contains the metal element X and is formed by the reaction shown. Here we have the metal sulfate reacting with sodium carbonate. 1.995 grams of the metal sulfate is reacted with excess sodium carbonate. Reacting with excess sodium carbonate is to ensure that all the metal sulfate reacts. So this forms 150 centimeters cubed of carbon dioxide gas at room temperature and pressure. They say calculate the relative formula mass of the metal sulfate using this data. Since this is excess, all this is going to react, and that gives me the volume of CO2 we see here, but they say they used room temperature and pressure, so I can use the molar gas volume in finding the number of moles of carbon dioxide. So moles of carbon dioxide should be the volume of carbon dioxide divided by the molar gas volume. Since I'm going to use the molar gas volume as 24 decimeters cubed per mole, I have to convert this volume in decimeters cubed as well. So 150 times 10 power negative 3 in decimeters cubed divided by 24 gives me the number of moles of carbon dioxide. So the moles of the metal sulfate are going to be twice the moles of carbon dioxide, since the ratio is 1 to 2, which is 1.25 times 10 power negative 2 mole. And to get the relative formula mass of the metal sulfate is going to be 1.995 divided by the number of moles, which is 1.25 times 10 power negative 2, and I got 159.6. There are no units here because it's relative. And finally, they said deduce the identity of X using your answer in C1. Since I have the relative formula mass of X sulfate to be 159.6, X is going to equal to the relative formula mass, which is 159.6, minus the MR of sulfate. MR of sulfate is 96.1, so 159.6 minus 96.1 gives us 63.5. And X is going to be copper, or you could say copper 2 plus, as the answer. So this brings us to the end of question 21, as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.